Hello students, in this lesson let us discuss about the geometric standards of the taxiway. So there are basically 8 elements of geometric standards of taxiway which we have to discuss in detail. So let's get started. So these are the 8 elements which we have to discuss. The first one is the length of taxiway, second one is the longitudinal gradient, third one is the rate of change of longitudinal gradient, fourth one is the sight distance, fifth one is the transverse gradient, sixth one is the turning radius, seventh one is the width of the safety area, and the last one is the width of the taxiway. Now let us individually study each one of it. So coming to the length of the taxiway, it depends upon the distance between the apron and entry aid, or the entry end you can say, or the exit end of the runway. How much distance is there between your apron and the entry and the exit end? Based on this, purely your length of the taxi will be limited. Normally the limiting length of this taxiway is not recommended by any of the organization, but in order to save fuel, what we should do is we have to keep it as short as possible, practically possible. Okay, so theoretically we can do any calculation, but practically it should be applicable. So this is about the taxiway. Moving on to the next one. The next one is your longitudinal gradient. Normally if your longitudinal gradient is too steep, steep means what? Too slope, more angle you can say, right, or more slope you can say. In this case your fuel consumption will be very high. So we have to make sure that we keep a nominal longitudinal gradient, not too heavy or huge, or not too low or less. So the standards according to the ICAO for your longitudinal gradient are as follows. So if you are going for A and B types of airport, the longitudinal gradient should be 1.5%, and if you are going for C, D and E types of airport, then your longitudinal gradient should be around 3%. Okay, moving on to the next one, it is the rate of change of longitudinal gradient. So for a particular length, how much it is changing, that is what is the rate of change. Normally the available sight distance on the pavement is affected by the rate of change of longitudinal gradient. So let's call the longitudinal gradient as LOGG. Okay. So basically how much of sight distance or visible distance is available on the pavement, that normally depends on your rate of change of longitudinal gradient. So there is a maximum which is fixed. More than this you are not allowed to give. Okay, so the maximum rate of change of your slope for 30-meter length of vertical curve, which is recommended by ICAO, is as follows. So for your airport type A, B and C, it is 1%, and for airport type D and E, it is 1.2%. So the next one is the sight distance. Normally what will happen is the speed of your aircraft on the taxiway will be less or lower when compared to the speed of aircraft on runway, because runway is used for landing and takeoff. So during landing also there will be certain speed, and during takeoff also there will be certain speed. But when it comes to taxiway, this is majorly used for taxiing it or like parking it. So normally here the speed will be lesser or lower. So what will happen is we will need a smaller values of sight distance in case of your taxiway, because basically we are fixing the geometric standards of the taxiway, right? Now with respect to this standards, the recommendation given by ICAO are as follows. So if you're going for airport type A and B, the surface of the taxiway should be seen for a distance of about 195 meters from, say, point 2.10 meters above the taxiway. So basically, if you are 2.1 meter above the taxiway and you are seeing the surface of the taxiway for about a distance of 195 meters, this should be okay for your airport type A and B. Now the same thing for your airport type C, D and E is, so same thing, but the numbers will change here. So instead of 195 meter, it will become 300 meters, and instead of 2.1 meter above the taxiway, it will become 3 meter above the taxiway when it comes to your CD and E type of airports. So I guess the taxiway design in terms of side distance is clear to you now. Now moving on to the next one is your transverse gradient. Normally this transverse gradient is given for quick disposal of your surface water. Okay, quick disposal of surface water. Compulsory, we have to provide the transverse gradient. Now according to ICAO standards, the maximum what we can give, more than that it is not allowed for you to give the transverse gradient. So the maximum given in the airport type A, B and C is around 1.5%, and in airport D and E the maximum we can give transverse gradient is about 2%. Now along with maximum there is also a minimum recommendation. So the minimum compulsory we have to give, I told na. So the minimum what we can give is generally not specified by ICAO, but according to standards it should be at least 0.0% transverse gradient. So this is just based on some standards, not based on ICAO. ICAO doesn't give any standards for your minimum transverse gradient. But according to FAA, the minimum transverse gradient you have to provide is about 5% for the first 3 meters of the taxiway, and then thereafter you can choose 2% depending upon whatever is the type of the airport. The next one is your turning radius, a very important feature out of all the 8 elements. So normally a horizontal curve is provided wherever there is a change in direction of the taxiway. Say now this taxiway is going like this, but we need to change its direction. So what are we basically providing? We are providing a horizontal curve. Because this curve is in horizontal plane, we are calling it as horizontal curve. It is provided for change in direction of the taxiway. Now it is very necessary to design the curve in such a way that your aircraft can negotiate it without significantly reducing the speed. So whenever the horizontal curve is being used by the aircraft, we have to make sure that there is no significant reduction in the speed. So in order to get this above feature without reducing the speed, what we can do is we have to give circular curves with large radius. And if you want to get the radius, you can use the formula r is equal to v square by 125 f. So where R is the radius of curve in meters, and V is nothing but your speed of aircraft in kmph, that is kilometer per hour. Compulsory, this should be in kmph, and then F is the coefficient of friction. And this coefficient of friction is between your tire and pavement surface, which is usually assumed to be 0.13 if it is not given. In case your airport serves large subsonic jet planes, normally for airports serving large subsonic jet planes, the minimum value of radius of curvature is taken as 120 meters irrespective of whatever is the speed of the aircraft. Same way, if we are going for supersonic jet planes, then the minimum recommended is 180 meters. Again, both of these are irrespective of the speed of aircraft. Now, if you observe this figure, it shows us the path which is followed by a supersonic aircraft having a wheelbase of about, so this wheelbase is the distance between the wheels of about 1.2 meters on the taxiway, and this radius of curvature is say about 60-meter radius. Now, according to a scientist called Heronjeff, the radius of curvature should be such that a minimum of 6 meters is maintained between the nearby main gear and the edge of the pavement, right? So between this point, that is the path of point midway between mid gear and the edge of the taxiway. So according to that, the formula will become what? 0.388 W square by 0.5 t minus s. So where r is what? R is the radius of center line of taxiway in meters. Then your W is the wheelbase of aircraft, again in meters. And T is what? Width of taxiway pavement, again in meters. And finally S is distance between midpoint, or you can say point midway of the main gear and the edge of taxiway pavement. Again, this value also is in meters. Now, what happens is, if the pilot maintains the nose gear on the center line of the taxiway, what is nose gear? The gear or the wheels which are in the front portion of the aircraft. If he is maintaining on the mid part of this main gear, mid path, or you can call the center line of the taxiway, having a radius as worked out from this particular expression, then the main gear of the aircraft would not come closer than 6 meter from the edge of the pavement. So like this, when you going, so from the edge of the pavement, it may not go above this 6 meter. Okay. If in case the existing airport has to be upgraded to the higher standard, that is, if you want to accommodate your supersonic jets in your existing airports, it may not be feasible sometimes to increase the radius of the existing taxiway pavement. So under such circumstances, what we have to do is we have to go for taxiway widening by giving extra width to the taxiway. Now, this taxiway widening can be seen here. This shaded portion is nothing but your taxiway widening, what we have done. If you observe, this is the center line of the unwinded taxiway. Okay, after widening, the path of the inner main gear is this dotted line. Okay, so what will be the expression? We can use these following expressions and find out the radius of widening which is required. Okay, that is to find the value of R1 and R2. So R2 will be equal to R, which is already the radius, into minus 0.388 W square by R plus S. Now, if this expression, say this expression gives a value which is less than 0.5 T, there is no widening for the required taxiway. And if it is greater than 0.5 T, then we have to work out for the radius R1. So your R1 will be equal to D square plus 0.5 T whole square plus 0.30 R minus R2 square minus RT, this whole divided by 2R minus R2, where your R, W, S and T are as we have discussed in the previous slide. Okay, now here the value of D will be equal to 3W minus 0.4R. Again, if your value of D is less than W, then what happens is we will have to use W in place of D. So this is about your turning radius. In the next class, we will solve a problem on turning radius for you to understand better. There are two more geometric properties that we have to discuss. So moving on, the next one is the width of safety area. So normally the safety area is made up of partially paved shoulders on either sides plus the area which is grained and drained. Okay, so it extend up to a point where it intersects a parallel runway, taxiway or a apron. Now before the evident of your jet aircraft, the shoulders were given either of the following two treatments. One is the shoulder would have been naturally protected with low growing vegetations, or the second one is by stabilizing using the granular material coating where the soil or the climatic condition do not permit easy maintenance of plantation. So by these two ways your shoulders were protected. Protection of shoulders before the jet aircrafts were invented. One is growing vegetation on either sides, and the second one is by using your stabilized granular material coating. Now, once the arrival of jet aircraft happened, it became necessary that we have to protect the shoulders from soil erosion, because what will happen is the jet which is coming out or which is exhausted from the jet aircrafts are at a very high speed. Hence what we have to do is a minimum width of 7.5 meter of shoulder should be given on adjacent side of your taxiways. Okay, and we have to make sure that it is paved with light strength material, and also we have to make sure that the material which we use, that is the light strength material, this should resist the air patrol vehicles or the sweeping equipments which are coming on those. And also we have to make sure that the shoulder should normally treated with bitumen so that surface wear out wouldn't happen, and the surface should be made up of such material that disintegration due to either the hot blast of the jet engine or due to the high temperature which is coming out of the jet engine will not cause any effect. And also we have to make sure that it should be smooth and impervious. So these are the things which we have to take care in the width of the safety area. Now finally is the width of the taxiway. This is normally very much lesser when compared to the width of runway. Right, now why is it so? It has two reasons why the width of taxiway is lesser than the width of runway. The first reason being your aircraft will not be airborne on your taxiway. Airborne is either landing or your takeoff. So aircrafts are not airborne of the taxiways. And the second is that the speed with which the aircrafts will move on the taxiway is very less when compared to the speed which they move on the runway. So hence what will happen is it will be possible for the pilot to stand in air easily on the small width of airway, that of the runway. So this is the typical cross section which you can see for the taxiway of airport type A and B. So if you observe, this is the taxiway width. These are the pavement shoulders. In taxiway, the gradient given, longitudinal gradient given is 1.5% maximum on either side. And for the shoulder, first 3 meters, it is 5% maximum, and then afterwards it is 2% maximum. Right, here the total taxiway width given is around 22.5 meter, and the pavement width on the sides is around 7.5 meter, and you can see there is a inlet drain on both the sides. Now, as I mentioned, the standard of the width of taxiway for airport type A and B is around 22.5 meters. For airport type C, it is around 15 meters. For airport type D, it is about 9.9 meters. And finally, for the airport type E, it is around 7.5 meters. Now, this is according to the ICAO recommendation. So these are the 8 criterias which we have to take care when we are designing the geometric standards of the runway. Hope this lesson is clear to you now. Thank you.